Hello everyone, welcome back. Before I begin, let me quickly introduce myself. My name is Verheyden. I'm currently working as a security architect at Proximus NXT. I also recently became a Microsoft MVP 3 months ago. I'm also active on the socials, on X and on LinkedIn. I'm mostly active on LinkedIn. I only got my own blog post on virtual.tech, where you can find tips and tricks around Microsoft security. I also got a GitHub, where you can find also scripts and KQL queries, but also an open source tool called MDE Troubleshooter. So if you have problems with developer endpoints, you can use that tool. But enough about me. Let's jump into the session, proactive exposure hunting with Enterprise Exposure Graph. Before we can start hunting, what do we need? We need data. And the data I'm going to use today is the data coming from Enterprise Exposure Graph, which is built on top of Microsoft Security Exposure Management. So let's start with having a look at what kind of product Microsoft has built for us, and how we can use that data from that product to do exposure hunting in your environments or in your client's environments. But first things first, what do the management platform need? It needs to know your assets which are running or being used in your environment. And obviously, they also need to know the weaknesses of those assets. And all that information is coming from different sensors and scanners in your environment. If you look at this slide deck, it's an official slide deck from Microsoft. You will see that there are currently Microsoft products, but also third-party products available. But it doesn't mean that all those products are already supported. But it shows you what kind of future plans Microsoft has with this product. So what sensors are supported at the moment? We got the default Microsoft connectors. We got Defender for Endpoint, for Identity, for Cloud Apps, for Cloud, for Office, for Vulnerability Management, for IoT and Entra ID. Also, there are third-party connectors currently available. If you have your assets in the CMDB in ServiceNow, you can use that. And then you got the 3 well-known vulnerability scanners like Qualys, Rapid7, and Tenable. Also, Wiz and Palo Alto Prisma Cloud is also supported. Something good to keep in mind is that that's currently in public preview. When it goes in general availability, it will be a consumption-based cost for every asset that is being ingested in the platform. So we know what scanners and sensors are supported at the moment. What will Microsoft do with all those scanners? With all those assets, they will enrich those assets. That can be with asset metadata, operational usage, configuration data, policy state, security findings, health state. And what the then will do is bring all those assets together and will start finding relationships of interconnections between all those different assets. This will be, of course, a continuous process of contextualizing. And the output will be an attack path analysis and a unified exposure insights. But that's not what I'm going to talk about today. What I'm going to talk about today is the Enterprise Exposure Graph and how you can use that. So what is the Enterprise Exposure Graph? It's a graph structural data source, and it consists out of 2 tables. There's the exposure graph nodes, that are the assets in your environments, like your devices, users, user groups, cloud resources, and so on. And you got your edges, and that are the relationships between the nodes in the graph. You already heard Olaf talking about it, but these are the 2 available nodes and edges that are available in the exposure graph. So let's have a look at those tables, and let's see what the data structure looks like, of the schema structure. So first of all, the things that we're going to use today to do the hunting is one of the most is the node label, that you can see it more like a node type. In this case, it's an example of a device. And also got the node properties. And the node properties, in this case, the rich data about the device. Because the node properties are the most important ones, and the one we will use the most to do the hunting. Let's have a look at those. And what you see over here, in this example, it's an example of a device. And what you see over here is that the metadata that's available, that can be onboarding state, OS version, if it's a server or an endpoint, the platform, and so on, even if it's domain joined. What else is available? This here, this data is coming from vulnerabilities management in Defender for Endpoint. In this case, what you see over here is that we got a vulnerability that credential guard isn't configured in the correct way. What else is available? Remote services running on that endpoint. What you see over here is like WUI running. SMTP is running. For example, you can even see that SMTP protocol version 1 is still enabled, or SMTP signing is enabled, or even if SMTP signing is required, it's also available. The same for RDP, WinRM, and RPC is also enriched information about that device. What also is available is the vulnerabilities insights. And you can see over here, what you see, that there is a vulnerability to remote code execution and a vulnerability to previous escalation. You can also see that there is a critical yes or no, or what the common vulnerability score is of that vulnerability. So all that information that you can use later on to do your exposure hunting. This is an example of a user. You see that it's an Entra user. And here you see the prime provider, and you still see a reference to Azure Active Directory, so they don't use Entra ID over there. And what else got you available, like the is still active, and also the assigned roles that you can see over here. So in this case, this user has the global reader, application administrator, and Azure DevOps administrators, and those are directly assigned roles. If you use privileged identity management, you will see that they will be visible here in the critical level. In this case, the application administrator and the global administrator. So that are roles that can be activated by using PIM. Also, something is important to know is the critical level. You see over here, or higher the critical level of the user, or lower the number is. So number 0 is one of the highest numbers that you can have for a user. In this case, of course, is a global administrator, so we will have a critical level of 0. Here's another example of node properties of a hybrid user in this case. So what you see over here, the primary provider is hybrid, the account is enabled, is active, sit if you want to use that. What else is the admin count is also available, and that's the sit history is also available. That's something that Olaf was talking about, that you cannot choose which configurations are visible, but that's Microsoft that chooses those information. But one of the points that you can search for is the admin count and also the sit history, which can be abused by attackers. What's also available is the Microsoft Defender for Cloud Security recommendations. I didn't use that yet, but it's also available. For example, what you see over here, there's an S3 bucket, which is currently unprotected, or unencrypted, I mean. So that information is also available. And one of the most interesting parts in my case is for the hunting is the CV. So for every CV is also available. And you also got the information about all those CVs. Even if Explode code available, is it public verified, is it part of Explode Kit, or even if it's a 0-day. So all that information is also available for your hunting. But that are not all the nodes, of course. This is an example of the nodes in my environment. As you see over here, 49 items are available. And what you see over here, like Entra user cookies are available, devices, cloud resources, users, base model, even AI models are available, CVs, groups, AWS user cookies, service principals, managed identities, all that information is all available in the Microsoft Exposure Graph. And you can use all that information to do your hunting. So let's start with a basic example, how we can hunt for, let's hunt for internet-facing devices with a previous escalation vulnerability. A very basic example, but it shows you what it's capable of. You got the nodes over here, and I didn't told you before, but the node properties is initiation structured data. So it's very easy to use in your KQL queries. You can use a dot notation. You'll see the raw data is internet-facing. In this case, it cannot be empty. What else is available is the ability to previous escalation. That it can also be empty. And we only want the internet-facing devices, so we also filter on the devices what you see over here. And if you run that query, you will discover all internet-facing devices with a previous escalation vulnerability. Then let's have a look at the exposure graph edges. And it's almost the same schema structure as a node. So we got an edge label over here. That's mostly an edge type. That's a relationship between a source and a target. We see here the source. In this case, it's a Defender for Cloud auditing recommendation. And here you see the target. In this case, it's a workflow in Azure. And here you also got the edge properties. And again, the edge properties is something that we're going to use later on to do our hunting on. Here's an example of those edge properties. So what you see over here, this is a relationship between a device as a source and that got the user, and that the device has credentials off. And what you will see, this information is from a test tenant. You can see that the credentials can be a primary refresh token that's stored locally on a device, or the NTLM hash is also something that you can see in your environment. So you can also use that to do your hunting. Here's another example, the hash permissions 2. And it's about OAuth permissions. And you see that it can be delegated permissions, but also application permissions that are available. So that's mostly a service principal has permission to, for example, the Microsoft graph. You will see that which permissions are available in the exposure graph. And this one from the on-prem environment has a role-on. You can see that the user has a role-on device, and you can see what user rights he has on the device, and also the logon methods that he's using. Also, is his local admin yes or no? So all that information is also available. Here's another example of has a role-on, but more cloud-related. You see over here that's a user that has permissions as an owner to a subscription in Azure. But of course, that's not all the edges or not all the relationships that are available. But here you see all the relationships I have available in my test tenant. So it can be also contains, runs on, member of, has permission to, is running, root traffic to, so all that information is available. There's an example of that I want to demonstrate from Stephen Lim, because this shows you what combining of correlating different tables, even with other tables, is capable of. So in this case, what he wanted to achieve was he had to get a critical Chrome zero-day vulnerability, which enables attackers to steal sensitive tokens, like OAuth, sensitive IDs, and more, simply by lurking users into visiting malicious sites. So what he did first, he did on a hunt to see which are his critical identities in his environment. So what he did, he created a temporary table based on the nodes, the category identities, and here he filtered on that the critical level needs to be lower than 4, so only the critical identities. He even filtered on his global administrators that he only showed the global administrators, but you can remove that line, and then you will get all the critical identities in your environment. And then he went on to hunt to find the vulnerable endpoints which has a cookie of those critical users. And that can be achieved by having a look at the table has credentials of. In the edge properties, there can be browser cookies, and you only want the target that has a critical identity. Just they only want devices with a browser cookie from those critical identities. And what he then did, he had a look at the device process events, and there he had a look at the Google Chrome with a vulnerable Chrome version. And there you only want the devices which are running the vulnerable Chrome version, which has a cookie of a user, which is a user that is critical in your environment. So as you can see over here, all those tables, by combining those tables, you can hunt for such vulnerabilities. What else is available is you can create your own graph structure. Olaf talked a lot already about it. So what I'm going to use today is also two operators, the make graph operator that generates your graph structure in memory, and the graph mod operator, where you can define your nodes and edges and the relationships between those different nodes, and even you can use it to filter. And let's show this with an example. Let's hunt for all devices we have a vulnerability that has user credentials with an Active Directory attribute admin count. Admin count is an Active Directory attribute, will be set to 1 if you have an important role in your Active Directory environment. So how does it look like? So you got your exposure graph nodes, and something I also suggest to do is start filtering early in your process, because otherwise it will be heavy and the query time will take a lot of time. So what do we need? We need our devices, because we want to know the devices with the vulnerability, just you can see over here. And what else do we want? We also want the users, and the users, that is an identity with the admin count to 1. And then we're gonna have a look at the edges, and this is just a one relationship between a source node and a target node based on a unique identifier, and this is a node ID. You also see that that I use the vun over here, so that's a temporary table I created. And what you can do then over there is then you can filter over here, because you only want to see hash credentials off. So if you run that query, you will get all devices with the vulnerability that says user credentials with attribute admin count. But how does it look like? As standard, you will see over here that you've got a table of all edges, sources, and target. Let's show you another example. OAuth applications with imported Microsoft Graph permissions, and that's something else that you can very interesting. So what you see over here, there is in the edge properties, the raw data, they got the delegation permissions and the application permissions are available. So we can use that to do the hunting. So let's hunt for those OAuth applications. And in this case, we're gonna create our own graph structure one by one. So we got our nodes up. This case is our source, which has a relationship can authenticate to as a service principal of can authenticate as, and that service principal has permissions to a node graph. In this case, the node graph is the Microsoft graph that you see over here. And also see the relationships, and we only want the relationships that we use here, can authenticate to, that reference to here, and has permissions to, that reference to, has permission to. Also, Olaf already noted this, but the names that you see over here, like node OAuth, can authenticate to, is totally up to you. You can choose your own naming convention over there. And in this case, we only wanted to filter on the important permissions, so we got directly read-write all, and the role management read-write directly, and upper role assignment read-write. So only want to hunt for those permissions. And so if you run that query, you will get all OAuth applications with imported Microsoft Graph permissions in your table. Now let's hunt for users that have any kind of role on those applications, which has app permissions to the Microsoft Graph. And it's the same that we did before, so this will be the same, but we added an additional part to it. So we filter on the node users which has the roles on the node application. So to begin over here, the edge has a role on, and let me check. We don't define over here what type of user it is. You just want to see all users which has a role on an application. That application can authenticate to service principal, and that service principal can have permissions to the node graph. But again, let's extend it a little bit further. How can attackers obtain credentials of users? Yes, on vulnerable devices with unprotected credentials running in memory. So the LSAP service is not protected, and they extract the credentials out of that machine. So what kind of credentials are available on that machine? And you can see over here. So we got the devices with RCE, so it's devices with a remote code execution, has credentials of a user, and that user has a role on a node app, which can authenticate to a service principal, and that service principal can authenticate to the Microsoft Graph. So as you can see over here, you can totally choose your own attack paths, and you can just play with it around. So it's, in my opinion, very helpful, and you can, you can have a lot of use cases that you can use by using this information. But what if you don't know how many relationships are between a source and a target? That's something that you can use is called a variable length edge. So what you see over here is that in our relationships, we currently cannot define how many relationships there are. So we say we only want 1 to 3 relationships between the source and the target. And that those relationships I want to search for, in this case, is the has credentials of, is the member of, and can authenticate to. Something to keep in mind is that if you use a variable edge, you cannot use a dot notation. You need to use graph functions, and those graph functions are over here. You need to use a map all of any graph functions to filter in the variable edge. In this case, I use the any, so any of those edge types of edge labels, has credentials of, member of, can authenticate to, is enough for me. And if you run that, you will get a lot of information. So let's show this with an example. Let's run for a 0-day to domain admins example. What we got over here, and we don't know the source, in this case, going to be a 0-day, and we don't know, we know the target, and the target in this case is the domain users. So very simple query. We got our target to be domain users, and our source simply the node. And then if you run that query, you will get all attack paths from that 0-day to the domain admin. Of course, we only want 2 to 6 relationships between the source and the target. So that's also something very helpful and that you can use in your own environment. But again, if you just print out the default output, and the default output is not very readable. So I got the same struggles as Olaf. I want to visualize it in a better way. What you can do is you can use the map functions for this in KQL, or the string category functions. The map functions, they go to each item, and then can you apply expression to them, and then we'll return a new list of an array of those results. And with the string calculate, you can take a list of strings and then join them together to one long string with a separator. So how does it look like? Oh, how does it look like? 1 second. How does it look like? In this case, first of all, we're going to loop through every edge in this case, and we only want the edge label and the target label, and we use a separator of an arrow. And then we're going to string concatenate the same results, and again using another separator and other arrow. And what does it look like? If you print that out like this, then you get this information. You got a source, has credentials of a user, is member of another group in this case, and is a member of a group. So that's much more readable as an attack path. But then next step is how do you visualize it? Like for example, if you have a look at advanced hunting, you can of it in the exposure graph. You can have a look at this, but I want to visualize it, the same problems that Olaf had. So that's how me and Henning met, because he showed me there was a new capability in the Kusto Exposure client, which can now build graphs and visualized capabilities. But what's the problem that I had is that with exposure, the Microsoft Exposure Management doesn't have an API available. So what I did, I used the Advanced Hunting API to extract the data to a JSON file. You need to be aware that there are limitations of 100 case rows. So what I suggest to do is filter on the node label. So you can create your queries that is just filter out only the labels that you want. And then you got the JSON file, and you can put those JSON files directly in Azure Data Explorer. They will recognize directly the schema, so that they're doing very good work there. And then you can start getting your queries in the Kusto Explorer client. And I will now demonstrate it, how that looks like. Just hopefully everything will be good. Okay. So this is my Azure Data Explorer cluster. And here you see the same queries that I used before can also be used over here. When I did that, I run again also to resource limitations, and that's also why I created a persistent graph model, also something that Olaf talked about. So I really suggest if you want to use that is also create a persistent graph model, because this information is mostly stable, it doesn't change a lot. So you can use a persistent graph model for this. So how do you create a persistent graph model? Is with this function. Just create or alter graph model, and then you can choose your name. In this case, I use the same schema is an exposure graph. As you see over here, you got my nodes with the schema, got my edges with the schema. And then you can create your graph model with add nodes. I used my demo nodes table and my demo node edges table. And if you run that, it will create a graph model, and you can show graph model. If you run it, you will see the graph models which I have available in my environment. You see over here, I created the exposure graph model and then demo exposure graph, which I'm going to use later on. The next step what you need to do is create a snapshot of it to materialize that, and that you can use to query create your queries to. That you can do with this example. So let me show you which snapshots I got available. Okay. Oh yeah. You only got this snapshot available at the moment. The other snapshots are already deleted. So what you can do then is, let me quickly scroll to the top. You can use over here, you can use that graph model to create your own graph structures again. So this is the same query. Here I want to query for local admin accounts with persistent graph model. So if I run that one, you will see that I get all the local admins, which are of all the local admins, of all the users which are local admin on my endpoint. So that's just an example. But now let's show you how to visualize it, and I'm gonna use this for that. So this is information from a test tenant. So normally it depending on the resources, but it only takes me 10 seconds to render the graph model. And it is a graph model where I didn't filter anything. So it's gonna take, you will see that normally everything's run good. So it takes some time. There it is. So it's loading, rendering now, and you will see that there's a lot of information. So a lot of nodes available, a lot of relationships available. So that's not very useful, but what you can do is you can use your filtering. So I'll let it load a little bit. Okay, so what I wanted to show you is again in the vulnerability. I want to see in a vulnerability what the impact will be of that vulnerability. And I want to see if there is a path available to domain controllers. So if I run that, and again, this is a very vulnerable environment, you will see. As you can see over here, I got 200 attack paths to domain controllers in my environment. So what you can do then is you can click on this, and then it will show you all the visualizations of that attack path. So that's also, in my opinion, very helpful. But what you also can do is then you can just click one by one all the attack paths, and then you see over here the attack path of that vulnerability. And if you move it a little bit, it can be sometimes a bit laggy. But what you can see over here is how the attack path looks like. So you get over here, if you click on it, you see over here the relationships affecting. So this is a vulnerability. If you click on affecting, and here, if you move that to the top, you will see also here the source node. So that's a vulnerability, and the target node is here a physical device. And that device has credentials of a user, and that user can authenticate to another device, and that device has credentials of another user, which is member of domain admins, and that can authenticate to a domain controller in this case. So that's the attack path, and now it's much more visible, and you can start working on those and start killing those attack paths. And in my opinion, it's much more usable this way than to have it in a stable structure. But what did Microsoft do? They listened to our prayers, and what they now created is a hunting graph. So one of the prerequisites to have this is that you need to be onboarded in the Sentinel data lake at the moment. So this is my test tenant. So what you can do is now you can click on the hunting graph, and this just, I think it's public available at the moment. So you got some predefined scenarios. So what you can do over here is you can create your attack paths between two entities, entities to access to a key vault, to sensitive data, to storage accounts, data exfiltration by a device, paths to high critical Kubernetes clusters, DevOps repositories, and SQL data source. Let me show you entities that have access to a key vault. And then you can define your key vault. Of course, another demo environment is not something special or something verbal, but I try to create some cases. Let me check all the relationships, just to be sure that I got everything. What you also can do, you can also start from a source node, but I'm not going to do this today. Yeah, normally if you run it, you will see the visualization of it. Ta-da, it looks like that. It works. And here you will see the attack path to that key vault. So in this case, there are a lot of attack paths. I got a test user which has permissions and role to that key vault. We also got a desktop that can has credentials of that user. So an attack path can be from that desktop that can has credentials of that user, and that user has a role or permissions to that key vault. You even see here, over here, I think this is an intra-user cookie, so I logged in with that user on that device. So if an attacker gets access to the device and it can extract the user cookies, it can also get access to that key vault. Here's another example. My guest user, let me see. My guest user has also access to that key vault. I think normally you can click on it, but okay, sorry, I wasn't informed. So my guest user is, has a role on this. I think this is a subscription. So there's an Azure subscription. And from here you can, of course, the resource group is part of the subscription. Normally, if you click on this, you will see additional data. I will wait, because now you will get an error. Normally, if you click on this, you will get additional data. But that's not working at the moment. So what you see over here is that the external user is owner on the subscription. So the attack path is that the external guest is owner on the subscription, and that subscription is part of a resource group, and then you can attack the key vault. Something else what you can do is you can also expand some, like this is my admin account, more from a blast ratios perspective. If you click on the plus sign over here, and then it will load the blast ratios of that user. What else is new and available is that the same is available in an incident at the moment. So this is a basic example. It's called the incident graph, and if you let it load a little bit, what you can overdo, you click on this, and then you can load the blast ratios from the incident. So that's also available, and then you will see that, let me narrow that a little bit. And just like this. So, and then here you see the attack path from that device. There is a malware when you run on that device. What's now the blast ratios of that device, and that is what you see over here in an attack path. So that's also very useful if you want to do investigations around that. That information is also available. So let me go back to my slides. So that's what I was talking about. So that's one of the prerequisites is that you are imported in the Sentinel data lake. So what's next? I'm currently working on an exposure hunting cheat sheet. It's mostly placed on Bloodhound, Active Directory, and Entra-ID cheat sheets, so that I can convert those Cypher queries that are being used over there and convert it to the exposure hunting in KQL. There are also a lot of hunting queries already available. Of course, KQL Search has a lot of those queries available. I also got some queries available on my GitHub, so you can always have a look over there. So that was it. That was everything. I don't know if there are any questions. Yeah. No, that's not, no. Because that's currently not available. I think why? Because it's really resource heavy. Oh, sorry. The question was if you can use the queries I created in the hunting graph in the GUI itself. So that's currently not available, and I know why it's not available, because it's really resource heavy. So if you run that query, especially if you don't know the different relationships between those attack paths, then it can take a long time to load, and sometimes you will run against limitations. So that's I think one of the reasons why they didn't implement it that way, and why they used those predefined scenarios. Any other questions? Someone want to use that already? Or does it excite you to use it? Or think you're useful? Yeah? Okay, that's good. All right, that was everything. Thank you.